Hi. Last video, I swear, for this lesson. All right, here we go. So we're going to look at solving systems of equations with substitution. And this particular system that we're going to look at is more difficult. Now, it's not going to be the most difficult system that you've ever done. You'll do more difficult systems later on. When you actually do your must-do practice problems, there's going to be some that are fairly complicated. That being said, this is going to be sort of the general structure that you can look at, or at least contemplate having to deal with in terms of a more difficult systems of equations problem. That being said, I need a lot more room, so I'm going to erase our steps. Hopefully you have written them down by now. Our steps are going to go away. I'm still going to be following them. I'm just not going to have them written on my board because I need more room. So our system is this time. We have 4y minus 5x is equal to 9, and x minus 4y is equal to 11. Let's make sure I wrote that down. Yeah, okay, I wrote that down right. All right, so here's our system. It's intense, yeah? If I look at this, I need to find, as I look at this, a nice way to potentially solve for at least one variable in one of these two equations. Looking at this, magically, thank goodness from the math textbook gods, we have this x all by itself right here. If I look at the rest of this though, like there's not necessarily a good option. So first step, I'm going to solve at least one equation for a single variable. And in this case, I'm only going to do one because the rest of it's pretty messy. So I'm going to solve the second equation in this system for one variable. So I'm going to start out by adding 4y to both sides, and oops, that's a y. So I get x is equal to 4y, that's an x, 4y plus 11. So that's the start. I'm now going to take this equation, this new equation, and I'm going to substitute this equation right here, 4y plus 11 in for this x, because I know x is equal to all of this. Instead of writing x here, I'm going to write this whole thing. Now, when I do that, though, this 5 is multiplying this x. That means this 5 is going to multiply this entire equation, meaning I'm going to have to add parentheses when I do this. So I'm now going to substitute this equation in here. So I have 4y minus 5x is equal to 9. Instead of writing x, I'm writing this 4y plus 11. 4y minus 5 times 4y plus 11 is equal to 9. And now I have to solve it. A couple of things that I'm going to pay attention to, just like when I solved equations for a single variable before in past modules, I'm going to rewrite this subtraction sign as plus and negative. So that way this negative, when I distribute, gets distributed into this parentheses and I don't potentially lose it in the process. So I get 4y plus negative 5 times 4y is negative 20y, and negative 5 times 11 is negative 55. Is equal to 9. And now I can start simplifying and I can start getting y by itself. So 4y plus negative 20y gets me negative 16y plus a negative 55 equals 9. I'm going to add 55 to both sides. So I get negative 16 is equal to 16y. Goodness sakes, I keep forgetting that y all over the place. What's my problem? Negative 16y is equal to 64. And I can divide by negative 16. And I get y, oh my gosh, it's getting really low, is equal to negative 4. Y is equal to negative 4. So I'm going to start writing my ordered pair down. So instead of writing a y, I'm going to write negative 4. And now I just need to fill in this x. So I've found one of my two variables, y equals negative 4. So now I'm going to take that information and put it into one of my original two equations. It doesn't matter which one you do. I truly don't care. I'm going to try to make it easier on myself. This one has a little bit of less work because the x is all by itself. So I'm going to put it into that equation, but you can truly put it into either one. It doesn't matter. So I'm going to put that y equals negative 4 in for y here. So I get x minus 4 times negative 4 is equal to 11. And I'm going to solve for x. negative 4 times negative 4 times negative 4 is positive 16. So I get x plus 16 is equal to 11. I'm going to subtract 16 on both sides. I get x is equal to negative 5. Now I'm done-ish. Now I really need to check my work, make sure that I have an ordered pair that truly matches this system. Because if you can see here, this was an intense problem. And this intense problem is something that you totally will need to be able to do as an algebra student. So I'm going to put this negative 5 in for x here and negative 4 in for y here and make sure it all checks out. So if I think about that, 4 times negative 4 minus 5 times negative 5, I need that to equal 9. 4 times negative 4 is negative 16. 5 times negative 5 is minus a negative 25. Negative 16 plus 25 is 9. Okay, so that one checks out. That's good. Now let's also check and make sure it works for the second one. We have negative 5 minus 4 times negative 4 equals 11. Negative 4 times negative 4 is 16. And then I have negative 5 is equal to, negative 5 plus 16 is equal to 11. And so that also checks out. So intense problem. This one was big. I had to use the distributive property. I couldn't solve for multiple variable, or I couldn't solve for a single variable in both of the equations. I had to deal with everything that was going on. But this is a great example of what proficiency in solving by substitution truly is. Like, you need to have this level of nuance for solving systems with substitution. Thank you for watching. If you have any questions, do not hesitate to ask. As always, I am here for you. Message me, email me, whatever you need to do. Thank you for watching, and I'll talk to you later. Bye.